Hi everybody. In this video, I'm going to go through our lesson, on multiplying radicals. And the first thing I want to discuss are the steps to actually multiply radicals. So step number 1 is going to be to multiply the radicands. And remember the radicands with a D at the end. Those are the inside numbers and variables. And then we will multiply the outside numbers and variables. So you have your inside pieces, you multiply those terms together, their inside numbers and variables together, and then you multiply your outside numbers and variables together, and then you will simplify. And you'll simplify the entire radical expression. So let's look at some examples. So first example, we are going to multiply and express in simplest radical form. So we have the square root of 6 times the square root of 14. And using the steps that we talked about above, the first thing we are going to do is we are going to multiply those inside numbers. So the square root of 6 times the square root of 14, that is really the same thing as the square root of 6 times 14. And if I actually multiply those two numbers and I type 6 times 14 in my calculator, or I write out 14 times 6, you will get 84. Oops. So I really am going to be simplifying here the square root of 84. Now we know two of the factors of 84, right? Two of our factors are 6 and 14. And I could set up a factor tree if I wanted to, and I could find, my factors of 6 and my factors of 14. So 6, that is 3 times 2, or 2 times 3. So 6 is 2 times 3. And 14, I can break that down into 2 times 7. And now looking at all of the numbers I have left, all of these numbers cannot be broken down any further. So if I'm going to simplify this radical, the square root of 84, really looking, I have a pair of 2's, right? I have two 2's, which means I can have 1 2 outside our radical to represent that one pair of 2's. And then what is left, the 3 times the 7, that stays inside. So 3 and 7 stay home, and this is all being multiplied, right? So I just keep the multiplication going. So overall, this would be 2 square root of 21. Another way you could do this problem, if you are, trying to solve or simplify the square root of 84, I might recognize some of the factors of 84, and 84 ends with a 4. So maybe if I just try, let's see, I'm gonna use blue. If I divide 84 by 4 in my calculator, I get 21. So that means 4 times 21 is 84. So I could rewrite the radical or the square root of 84 as the square root of 4 times 21. And that's really just the square root of 4 times the square root of 21. And the square root of 4 simplifies to 2. So this is really 2 square root of 21. So there are two different ways you can simplify the same radical using your factor tree or using this kind of finding a factor that is a perfect square. But either way, multiply the inside numbers first, and there weren't any outside numbers here to multiply. Example 2, we are going to find the product in simplest radical form. And we're going to multiply -4 times the square root of 3 times 3 square root of 30. So if I'm going to multiply these three together, really, I can multiply maybe these two together first. So maybe I'm going to multiply -4 times the square root of 3 together first, which really, I mean, -4 doesn't even have a radical involved in it at all. So this would just become -4 times the square root of 3, or -4 square root of 3, times 3 square root of 30. And now to simplify this, or to actually multiply, I'm going to begin by multiplying our inside numbers, and our inside numbers are 3 and 30. So underneath the radical, we're going to multiply 3 times 30, those inside numbers, and then outside of the radical, we will multiply the outside numbers, -4 times 3. And -4 times 3 will be outside. So multiply your outside numbers together, multiply your inside numbers together. And now let's actually multiply. So -4 times 3 is -12. And then we have the square root of 3 times 30, which is 90. So we have -12 square root of 90, which is not in simplest radical form. So if I'm going to write this in simplest radical form, looking at that 90, I notice that 90 is divisible by 9, and 9's a perfect square, right? 90 divided by 9 is 10, which means that 9 times 10 gives me 90. So keeping that in mind, I can rewrite this as -12 times the square root of 9 times 10 instead of 90. And then I can break it up. I can write this as -12 square root of 9 square root of 10. And remember, this is all just multiplication here. It's just in disguise. We don't necessarily need those symbols. But it's important to remember because once I simplify this, the square root of 9 is 3. So I have -12 times 3 times the square root of 10. And -12 times 3 is -36. So I have -36 times the square root of 10, or -36 square root of 10. And you really just multiplied, finally, -12 times 3. All right, number 3. We're going to multiply and express in simplest radical form. And we're multiplying the square root of 15a squared times 4 square root of 5a squared. So looking at this example here, first things first, we're going to multiply our radicands, or the numbers inside the radicals, together. So I'm going to have a radical here with 15a squared times 5a squared. And then I also have this only outside number, right? I have this 4. And then I also have kind of like this invisible 1 here. So 1 times 4 gives me just a 4 on the outside of this radical, and it's being multiplied, but I don't necessarily need to write the multiplication symbol. Now, when I'm actually multiplying underneath that radical, you can multiply numbers with numbers and variables with variables. So really, this is the same thing as 4 times the square root of 15 times 5 times a squared times a squared. Just rewriting the order of the multiplication. I'm multiplying the numbers together and I'm multiplying the variables together. And this is the same thing as 4 times the square root of 15 times 5 is 75. And a squared times a squared, well, that is 2 plus 2, or 4 a's being multiplied all together. So now my goal is to simplify this 4 square root of 75, a to the 4th power. And this is the same thing as 4 times the square root of, breaking it apart, 75 times a to the 4th. So I can really look at this separately. It's 4 times the square root of 75 times the square root of a to the 4th power. So let's talk about the square root of 75 first. 75, if I think about how many quarters I would have in 75 cents, I'd have 3 quarters to make up 75 cents. A quarter is worth 25 cents. And why did I bring that up? Because 25 is a perfect square. So 25 times 3 gives me 75. And I just remembered that knowing what I know about money. So 3 times 25, or 25 times 3, gives me 75. So we can really just write this as 4 times the square root of 25 times 3 times the square root of a to the 4th power. And keeping on simplifying, we can break this radical up. This is 4 times the square root of 25 times the square root of 3. So just breaking what we know about this radical up. And then that is being multiplied to the square root of a to the 4th power. All right, now the square root of 25, like we talked about, it's a perfect square. The square root of 25 is 5. So I have 4 times 5 times the square root of 3 times this a to the 4th power. And let's talk about this, or sorry, square root of a to the 4th power. I recognize that exponent of 4, that's an even exponent, right? So if I write out a to the 4th power is 4 a's being multiplied, and I could create 2 pairs of a's. If I divide 4 by 2, that gives me a squared. So a to the 4th power, the square root of a to the 4th power, you simply divide 4 by 2 and you get a squared. No square root involved, because we were able to create 2 pairs out of the 4 available a's. All right, so let's put it all together and see what we get. 4 times 5 we can multiply. That gives us 20. So we have 20 times the square root of 3 times a squared. and put all of your outside terms together at the front. So we really are multiplying 20 times a squared, and then we'll have this square root of 3 at the end. So I would write this as 20a squared square root of 3. All right, I want to do one more example. This is the final answer for that one. Number 4, multiply and express in simplest radical form. So we're going to multiply the square root of 2 times 7 minus the square root of 2. So if I'm going to multiply one term by something that has 2 terms, I'm going to distribute this square root of 2 to both the 7 and to the negative square root of 2. So when we do this, we're going to multiply. So I have the square root of 2 times 7, and then I might just write this as minus the square root of 2 times the square root of 2. And the square root of 2 times 7, I mean, one of those numbers does not have a radical and one of them does. So I'm just going to put my number without a radical first. So this is 7 times the square root of 2. Think of 7 as like your coefficient. X times 7 is 7x. So I have 7 square root of 2 minus the square root of 2 times the square root of 2. If we actually think about that and we follow the steps of multiplying radicals, we would multiply 2 times 2 to get the square root of 4. And we recognize that the square root of 4 is 2. So I have 7 square root of 2 minus 2 as just a whole number. So if you have a square root, if you have a square root of a number times a square root of that same number, the square roots really just cancel each other out. It's like the square root of x squared. It's just going to be whatever that common radicand is. So we really have 7 square root of 2 minus 2. And a lot of times we could write it like this, or we could also flip the order of our addition. So instead of 7 square root of 2 plus negative 2 instead of minus 2, I could flip this and write this as negative 2 plus 7 square root of 2. Either of these two expressions mean the same thing, and they're in simplest radical form. Please let me know what questions you have on this section.